Okay, after talking about the different types of compressed tablets, now we want to talk about their manufacture. But remember, I said tablet by compression can be prepared by direct way or indirect way. إذن في عنا الcompression can happen by direct or indirect. طب شو الفرق? What is the difference? The direct is that your mixture of drug and other excipients are directly compressed. Okay, هل في هناك عملية drying? No, because I'm not doing any wetting or any granulation, and that's why we call it direct. طيب indirect can happen by wet granulation or dry granulation. إذن here it's indirect. Why it's indirect? Because first we need to do granulation, whether it's wet or dry. Because we need to do granulation, we refer to it as indirect. يعني إذن first we need to prepare granules, then we can compress them. طيب, so this is one way of classification. So we can classify the way to produce tablet by compression as direct or indirect. Also, we can classify the way to produce tablets as dry and wet method. Then this is another way of classification, اللي هي dry method or wet method. If I classify it as dry method and wet method, فالdry method راح يكون جواته direct compression and dry granulation. لأنه dry granulation I'm not using any liquid. أما الwet method فهي indirect through wet granulation. You got it? يعني I can say here dry methods و wet methods. في الwet راح يكون عندي الايش؟ الwet granulation. طب في الدراي شو بكون عندي؟ اللي هو direct compression وهذا 1. the second اللي هو ايش؟ اللي هو dry granulation. Okay, this is another way of classification. So let's look at the different process and discuss them. الwet granulation اللي هو indirect method. See, first I have to control the size of the drug and the excipients. Number 1. Number 2 will be mixing. So I have to prepare a uniform mixture. Number 3, I need to add the binder solution. I need to add the adhesive liquid. So here, while I am mixing the powder, I need to add the liquid and allow the liquid to mix well with the ash, with the mixture of the drug and the other adjuvants. Other adjuvants include ash, disintegrating agent, diluent. These are the most important 2 adjuvants that are added here. Now, sometimes I do not add the whole quantity of the disintegrating agent at this step. I may add only half of the disintegrating agent here, and the other half I add it to this step here. Later we will see. So I either add all of the disintegrating agent here, or maybe better, add half here and half later. طيب, then you add the binder solution or adhesive solution, and you know why we need to add the binder solution. This is to allow the particles to stick to each other, and you will have wet powder here or damp powder here. Then it's better, before you dry the damp powder, it's better that you granulate your wet mass to make them or to cut them into small pieces. Why? Later on you are going to dry them, right? So if they are smaller in size, the drying will be better and more uniform. فإذا because of I want the drying to be better, usually I break them to smaller pieces in this step. How can I do that? Well, later we will see. After you dry your wet mass, this step is very important because you need to control the granule size. So you will force your dried granules, you will force them through screen or sieve that have openings less than the ones that you use here. Here the granules, you need smaller granules, so you will force your dry mass through the dry granules through the screen here that have openings that are smaller than the sieve that you use here. طيب, after that, you need to add lubricants. Lubricants include واحد, as I said previously, glidants, lubricants, anti-adherents. Some material can function well in the three categories like magnesium stearate. Sometimes we may need to add also a glidant. طبعا, before you add the lubricant, lubricants are usually added the last step just before compression. You will add the disintegrating agent. If you didn't add all of them here, then you will add half of them here. And the last step is usually lubricant. And lubricants are usually, especially when I'm talking about magnesium stearate, is usually added the last step, and usually I do not want to have uniform mixture like other ingredients. In case of lubricants, magnesium stearate, which is very hydrophobic, I do not want it to get mixed very, very well in the mixture. This is maybe the only ingredient that I do not intentionally mix it very well. And the reason is, if I mix it very well, magnesium stearate will start positioning itself between particles. And when it does that, and I want to do compression, it will prevent granules and particles from sticking to each other. لأنه هو أصلا lubricant, هو it doesn't allow sticking to happen. That's why I only need the lubricant to be in the outside of the formulation. I do not need the lubricant to be inside. If it is inside, then it will prevent forming the tablet, prevent the tablet from having good strength, good mechanical strength. That's why I'm not really concerned with getting a uniform mixture in this case. فإذا we add lubricant the last thing in the process. طيب, في dry granulation, and we already discussed these two processes maybe in powders and granules. We discussed that. For dry granulation, first you control the size of the drug and the other excipients, then you mix them, you blend them. Here again, you might add all of the disintegrating agent or half of it, okay? In any way, after you do the mixing with the diluent and the disintegrating agent, you take it to a roller compactor, roller compaction machine, okay? فإن this machine, طبعا either roller compaction machine or you will use a slugging machine, So in this machine you will compress your powder. إذا كانت roller compaction machine في بيطلع عنا هين إيش compacted sheets. إذا عنا slugging بيطلع عنا slugs like a tablet, okay? طيب, what caused them to stick to each other? ليش الضغط, why the compression here in this step will make the particles stick to each other? Is there any reason for this? Well, there is a reason. The reason is the van der Waals forces, which you probably studied in Physical Pharmacy 1. when you bring particles together, the closer you bring them together, the more forces of attraction they will have to each other. So by compression in this step, I can enlarge the powder that I have into big pieces, whether slugs or compacted sheets, but then I need to crush them, and then I need to control the size of the granules through sieving. And then, as I said, if you did not add the whole disintegrating agent here, then you can add part of it in this step. And the last thing is that you add lubricant such as magnesium stearate, and eventually, or the last step is to compress them into tablets. Okay, this is the dry granulation. طبعا, is there any drying? ما في عندنا عملية drying because I'm not adding any liquid. Is there any wetting process? لا. فإذا you have maybe less time here because you do not need to do drying and wetting in this process. Okay, the last step is direct compression, and as you see here, there are much fewer steps than the indirect compression, whether it's by wet granulation or dry granulation. First, you need to make sure that the particle size of the drug and other adjuvant is according to your requirement. Then you blend them. طبعا, adjuvants include usually directly compressible vehicle. This is a diluent that will help or will aid the formulation to be directly compressed. And this is actually a reason why we usually prefer granulation. We prefer granulation because the granules are readily compressed because you will have a binder in the formulation. Here you don't have a binder. Actually, the binder needs to be usually, because the drug, most drugs are not directly compressible. That's why the diluent that we choose is a diluent that is able to make the formulation bind together upon compression. That's why we use directly compressible vehicle. So we mix the directly compressible diluent or vehicle along with all of the disintegrating agent and lubricant at the end. We mix them and then we take them for compression to get tablet. So as simple as that. Now, if someone asks, why don't we just go for direct compression? One reason is, حكينا, not all drugs are directly compressed. Actually, few of them are. And that's why we need a special diluent to make the formulation directly compressible. A second reason, probably because of flow. Now, granules are bigger in size and they flow very well. And in industrial scale, we need good flowing formulation. Granules are bigger. If we don't make granules, the flow will be most probably a problem. Okay? That's why we prefer the granulation way, the indirect way. Here I forgot to say that DiTab is the trade name for dibasic calcium phosphate, اللي هو inorganic diluent that we talked about في الكبسول formulation. Okay, most agents, most drugs needs excipients, as we already talked about before. This includes the binders, disintegrants, diluents, lubricant to get the desired characteristics. Granulation, as I said just a little while ago, will allow the flow to be better compared to the case when we have direct compression. Granulation, as I said, has better compressibility characteristics. يعني the way the binder distributes in the granule, طريقة توزيع البايندر في الجرانيول when we do wet granulation is allowing the granules to be compressed in a better way compared to other or compared to the direct compression. So let's talk about each method, maybe in little more details. Wet granulation, this is the most widely used method, and as I said, it's widely used because we are producing granules that are free flowing, and because of the binder distribution in the granules. It's widely used method. It involves weighing and blending the ingredients. طبعا before blending them, we need to make sure of the particle size, especially of the drag. After blending, mixing يعني, after blending we need to dam the mass to get wet mass. After wetting the mass by adding a binder solution, we need to break this wet mass by screening the dam mass into granules. Then we need to dry the granules, and then this is very important step, we need to control the size of the granules. We don't want granules, some of them to be big, some of them to be small. So we unify, or we allow the granules to be produced within certain size range. طبعا if there is some disintegrating agent to be added, it will be added after sizing the granules, it will be added, and the last step will be adding the lubricating agent, and then the process of compression. Regarding the diluents that we use, lactose is one of the frequently used diluent because it's compatible with almost all drugs. The same is with microcrystalline cellulose. These two are the most commonly used diluents. Lactose is water soluble, microcrystalline cellulose is not. We have also starch, sucrose, dibasic calcium phosphate. So there is a wide range of diluents that we can use. The homework you have is what are the factors affecting which diluent do I need to use. And I will show you these factors. Let me see if it is in this document or maybe another one. No, not this one. So let me see. Okay, choice of tablet fillers. Here it explains to you what are the factors. The choice of filler usually is based on the experience of the manufacturer with the material. Yani if my experience is with lactose, for example, and I have good experience with lactose, I don't want to try something else because it might not be good enough. I have experience with lactose, so I will use lactose. Another factor that affect the choice اللي هو الcost. Another reason اللي هو أو another factor اللي هو compatibility with the other formulation. مثلا على سبيل المثال, for example, I cannot add the dibasic calcium phosphate اللي هو calcium salts. I cannot add it to a tetracycline antibiotic formulation. Why? Because calcium will, في diluent, will interact with the tetracycline, and this will retard or reduce the tetracycline absorption in the GIT. Okay? So you need to answer the question here and submit it by email to me. Okay? طيب, disintegrating agent, these include cross-carmylose, and if you remember, this is a super disintegrant which I can use in tablets. في عندنا corn potato starch, في عندنا sodium starch glycolate, برضو this is a super disintegrant. في عندنا كمان sodium carboxymethyl cellulose, وفي عندنا polyvinyl pyrrolidone, في عندنا cross-povidone which is also a super disintegrant. طيب, حكينا, we said this, إنه portion of the disintegrating agent is added at initial blending, and the other half may be added at the end before adding the lubricant. If we do that, we will have what we call double disintegration of tablets. Double disintegration of tablets. Yani, if we add the disintegrating agent in two portions, one in the beginning before making the granules and one after drying the granules and screening it or sizing it, so I will have what we call double disintegration of tablet. What does it mean? Now I will draw this for you. Okay, now if I add it before making granules, then the granules that is formed, this granule will contain a disintegrating agent. And when I add the other portion after making the granules, then the disintegrating agent will be also in the outside. Isn't? If I add it in two portions, disintegrating agent will be inside the granules and outside the granules. So when I want to make tablet, and this tablet is made of granules, and these granules are surrounded by, in addition of course to glidant, etc., it is surrounded by disintegrating agent, and disintegrating agent is also inside these granules. شو بصير عندنا؟ بصير عندنا what we call double disintegration of tablet. يعني the tablet will break easily into fragments, into granules, because there is a disintegrating agent between granules. Okay? So the tablet will break, giving granules, and then granules themselves, they will also disintegrate because they contain a disintegrating agent inside. وصار عندنا what we call double disintegration. One, disintegration of tablet, then disintegration of granules. If I only have the disintegrating agent inside the granules, then I will have only the disintegration of the granules. Okay, yes, the tablet will break because the granules are absorbing gastric juice, and this disintegrating agent will swell or will wet, causing the granules to break. But that is one-step disintegration. But in double disintegration of tablets, you have the breakup of tablets because of disintegrating agent between the granules, and then the granules will break because of disintegrating agent inside. طيب, preparing the dam mass. Here I need to dissolve, usually in water, is and most liquids that we use to prepare wet mass, they are based on water. So we dissolve, for example, povidone, والpovidone هو polyvinyl pyrrolidone. We also can prepare cornstarch in a percentage of 10 to 20. We can prepare glucose solution, 25 to 50. We can prepare methyl cellulose, only 3%. Or we can use sodium carboxymethyl cellulose or microcrystalline cellulose. You will notice that some of these names, you have seen them as diluent, you have seen them as disintegrating agent, and here you are seeing them as binder. زي الcornstarch مثلا. This is diluent, binder, disintegrating agent. Microcrystalline cellulose, it helps disintegration as well, and it's a diluent. طيب, you will notice that we are using different percentage, and these are related لإيش? To the power of the binder. If the binder is powerful to bind the particles, then I need to use only small percentage. If it is not so powerful, then I need to use large percentage, as the case with glucose solution. طيب, now what happens if I want to use the wet granulation method to produce granules, but the problem is water might degrade some drugs. So in this case, I have options, either to substitute water with non-aqueous liquid, or let's say with alcohol, for example, or I will go for the direct compression or the slugging method or roller compaction method, the dry granulation, to produce the granules. طيب, when we do, or when we intend to prepare the wet mass or the damp mass, you need to be careful from overwetting or underwetting. Overwetting يعني I'm adding more of the binder solution. Underwetting يعني I'm adding little of the binder solution. طيب, what will happen if I am doing overwetting? بصير عندنا الماس is overwetted. After I wet my mass, and I'm doing overwetting here, and then I want to produce or screen the granules or the wet mass. The wet mass will form threads, يعني بصير ينزل على شكل threads instead of coming down as granules. They will come as threads. I don't know if you can imagine the minced meat. When you want to grind the meat and mince it using the machine, you will see that the machine, with the auger inside the machine, is forcing the meat that come out as threads. يجوا مثلا واحد بده يسوي for example لحم ناعم للكباب or etc. They come out as threads. فإذا if I am overwetting شو بصير عندنا؟ بصير عندنا difficult to granulate because they come out from the screen as threads. وهاي الثreads difficult to break. If I am doing underwetting يعني I'm adding little, معناته there will not be enough binding between the particles, and the particles will come with little granules formed, and even the granules that are formed will break easily, will crumble easily, will be fragile or brittle. فإذا I should not do overwetting or underwetting. There is what we call granulation endpoint. يعني because we don't want to do overwetting or underwetting, we must stop at certain point. High point usually is known by the experienced in the field. طيب, after you produce the wet mass, you want to do what you see here, اللي هو the granulation step, screening the damp mass into pellets or granules. We can do that by hand, يعني we force the wet mass through a sieve, or with special equipment. This special equipment as the one you see in the figure here. Okay? If you look here, we will add the wet mass, and then here we put the tray to receive the granules, and inside this one there is what we call oscillating granulator, يعني bars like what you see here, rotor bars, that rotates in both directions, this direction and this direction, to force the moist powder or wet mass, to force it through a screen or sieve. Then here we are fitting a sieve, and the wet mass is added, and this will force the wet mass to break through the sieve and down into a tray. إذن هنا بيكون في عنا إيش؟ a tray. إذن here we have a mesh or a sieve. وهون في عنا rotor bar inside. We add the wet mass from here, and this will work. So the wet mass will fall down here. طبعا, as you see, if we leave the tray like that, the wet mass will form a heap like this. That's why you need to move this tray right and left in order to distribute the granules that fall from here into the whole tray, عشان يكون evenly distributed in the tray. What do you do with this tray? طبعا you take it for drying. One of the most commonly used dryer اللي هو tray dryer, tray. من صينية يعني tray يعني هاي التray. Okay, this is the tray. So you take the tray dryers, there will be several of them, maybe 20 trays or 10 trays, and you'll put them in a tray dryer. Okay? I will show you in a video how the oscillating granulator works, so that you get an idea of how granulation is done. You can see his hand beneath the mesh, just for you to know. Yeah. Okay, after you dry your granules, you take them out, you take the trays out, and this is very important step. You need to control the size of the granules. Usually we need the size to be from 0.85 millimeter to 2 millimeter. However, the size of the granule is related to the size of the tablet. If you have a big tablet, usually the granules are larger. If you have a smaller tablet, usually the granules are smaller. Why we need to size the granules? We already did that before we dry the granules, صح? After we get the wet granules, how do we get them? By sieving them. Now, why you need to do sizing again? طبعا, the granules that you get as wet here, they may stick to each other. Some of them might shrink. So there will be different sizes of granules. That's why you need to control the sizes. Okay? And the more uniform the granules, the better. So you need to control the size range of the granules so that no segregation can happen between them, and the granules flow will be better. After you size your granules, you need to add the rest of the disintegrating agent if you want to use two portions, one in the beginning, one in the end. And the last thing is adding lubrication. Now, lubricants, as already explained, may be glidant, which improve the flow, and this طبعا improving the flow will allow the formulation اللي في الهوبر. Okay, because you take the formulation to the hopper. من الهوبر بروح وين? Where does it go from the hopper to the hopper shoe? من الهوبر shoe وين بده يروح? It will go to the dye cavity. فإن order for the formulation to flow easily into dye cavity, you need your formulation to have excellent flow. That's why you will need to add glidant. Also, in addition to glidant, you will add lubricants and anti-adherents to prevent the tablet formulation from sticking to the punches. في عندكم lower punch or upper punch that will compress the granules. If they stick to the punches, then you will have tablet with rough surface, pitted surfaces. Also, you don't want the tablet inside the dye cavity to stick to the wall of the dye cavity. فإذا في عندنا sticking to the wall of the dye cavity, في عندنا sticking to the punches. I like to call it picking. Okay, I like to call sticking to the punches picking. We sticking to the dye wall sticking, just to differentiate between the two. But you can use both terms. So the lubricants, they are supposed to reduce the friction between the tablet and the punches and the dye wall, and the good thing is that they give sheen. لمعان أو smoothness to the finished tablet. As I said, lubricants are dusted over through a fine mesh screen على الgranules. As I said before, we don't really want to have a uniform mixture of lubricant with the granules. Don't forget that lubricants are added in very small quantity, usually less than 1%. Okay? وبتعرفوا when you mix something very small with something very large, you need geometric dilution to have uniform mixture. We don't do this. We don't really need to have uniform mixture in this case. Among the commonly used diluent, we have magnesium stearate, calcium stearate, stearic acid, talc, sodium stearyl fumarate. Remember, this one is hydrophilic lubricant. If you go back to capsules, you will see this name. في الwet granulation, in the topic powders and granules, we also talked about fluid bed process. And I believe you remember the video that I showed you where your powder is loaded في conical part of the fluidized bed machine, and the air comes from below. It agitates the powder. So what will happen? It will get mixed. بعدين you'll spray the binder solution. After that, after you complete this process, you dry your granules here while they are fluidized. Okay? You see here a big fluidized bed granulator with a man standing here to see the difference in size between this man and this big machine. طبعا there is also a small machine that you can put in the lab, a benchtop granulator. Okay. طيب, dry granulation. This method is especially suitable متى؟ Dry. يعني you don't add liquid. When your drug is sensitive to water and sensitive to heat. يعني in these cases, think about dry granulation. In this process, your powder mixture is compacted first, whether through slugging or roller compaction, and then it's broken down and then sized into the granules. And it's very important here that the particles that you deal with, or the powder mixture that you deal with, should compact when you apply pressure to them. If they don't compact, معناته it will be difficult to prepare granules by this method. طبعا you remember in the topic powders and granules that we have two ways to prepare granules by dry granulation, اللي هو slugging. في slugging, as I said previously, you produce large flat tablets. These can have a diameter of 1 inch. 1 inch يعني how many centimeters? يعني 2.5 centimeters. And it will be thick. Thick, it can be 1.5 centimeter. يعني they are not to be swallowed. After that, you take slugs, you break them with a mill, and then you screen them to control the size of the granules. طبعا when after you finish that, you can add the rest of the disintegrating agent, okay? Because before slugging or compression, you need to add disintegrating agent. If you don't add all the disintegrating agent portion of it, then you can add it after sizing. The last step is to add lubricant, and then you can do the compression as with others. The roller compaction is more used for the dry granulation. It's preferred. The reason why it's preferred, it doesn't apply the high pressure to the powders as in the case with slugging. يعني in the case of slugging, you will need a mill. But in case of roller compaction, you may not need a mill. You can actually break it up with your hand or with the machine that do the sizing. طيب, so you follow the same process as described previously. Direct compression. We need here to have a free-flowing, okay, material that is also cohesive. Okay, free-flowing because I told you that in direct compression the main problem is one, the flow. طيب, the other problem is ايش حكينا, compressibility. Granules are better compressed than powders. That's why you need the powder to be free flowing and cohesive. Now very little drugs are having such characteristics. يعني potassium chloride might have such characteristics. طيب, that's why in many cases we go for directly compressible vehicle. يعني vehicle that can turn the formulation and make the formulation compressible. Now you cannot use directly compressible vehicle if your drug, the drug you are using is in large dose. يعني for example, if my drug is 1 gram and my drug is not directly compressible, then I might need 2 grams of directly compressible vehicle to make the formulation compressible. So the total will be at least 3 grams. Now 3 grams is a very large quantity for a unit dosage form, for a tablet to be swallowed. طيب, if the drug quantity is smaller, like 100 milligram for example, then I can use such vehicles, directly compressible vehicles, including spray-dried lactose, microcrystals of alpha monohydrate lactose, microcrystalline cellulose, اللي هو الأفيسل if you remember, crystalline maltose, dibasic calcium phosphate. Disintegrating agent, like similar to what described previously, include starch, include sodium carboxymethyl starch, cross-linked carboxymethyl cellulose اللي هو cross carmylose fibers, وفي عندنا كمان cross-linked polyvinyl pyridone اللي هو cross povidone. اوكي, هدول super disintegrants. Lubricants, magnesium stearate and talc. Glidants اللي هو silicon dioxide, colloidal silica. Okay. Now we want to talk about the tableting process. Okay, tableting process. Here I'm talking about the tablets prepared by compression. First, I want to introduce you to the main part of the machine that will do the compression of the tablets. Look here. What you see here is the upper punch. Okay, so this will be here at the top of this one, it will be on the top. Okay, what you see here is the die plate or the die, القالب. And what you see here is the die cavity. What you see here is the lower punch. Okay, now I will explain to you the process with a figure, but first let us explain it here. See, when I want to fill a material, this material comes from a hopper shoe. يعني here I will have a hopper shoe, okay, coming from a hopper. It will fill the material in this place. Okay, now if I lower the lower punch more, I can fill more quantity. صح? If I take it up, the quantity that is filled will be less. So how do I control the weight here? I can control it by the lower punch. Then the lower punch will be responsible for controlling the quantity. But the problem is, شو المشكلة? If I want a tablet with, let's say, 500 milligram weight. How can I know that this space is 500 milligram? I cannot know. This is a problem, because what you have here is a volume. So you want a volume that corresponds to the weight you require. You require 500 milligram. So what do I do? What's the solution? What do you think is the solution? Well, the solution is trial and error. Yani, first, give a certain space, produce some tablets, and then weigh them. If it is 400 milligram, معناته in this case, what do you need to do? You need to decrease this one so that you leave more space. Okay, so decrease it a little bit. Try again. If it is 550, what do you need to do? Okay, you need to raise it a little bit until you get your required quantity. For example, as I said, 500 milligram. طيب, after the formulation gets into the die cavity through the hopper shoe, the hopper shoe must leave the place and the upper punch must descend to do the compression. So you will have a tablet formed. إذا هون راح شو يصير عندي? Here, what will I have? I will have a tablet formed here. Okay? طيب, now a tablet is formed. What should happen? The tablet must be ejected. So the lower punch must travel upwards to the surface to put the tablet when على surface. When the tablet goes to the surface, what happens? The hopper shoe comes back and ejects, removes the tablet from the surface. When it does that, the lower punch goes down to the previous position to fill another 500 milligram of the powder from the shoe. And then the cycle continues. يعني the shoe goes back, the upper punch goes down, and the compression happens again. Okay, I want you to see this. This is the foot or the shoe of the hopper, where the formulation falls down. As I said, we control the weight here through lowering or raising the lower punch. Okay? After that, the shoe must leave and the upper punch will descend. If the shoe does not leave, شو بصير? the upper punch comes down and it will break or make a hole in the hopper shoe. And this happened actually while I was doing my PhD. We had a nice tableting machine in the lab, and because there was a mistake made by the operator, the shoe did not leave the place. طبعا the shoe must leave automatically. في هناك automatic way that the upper punch descends only when the shoe leaves. By automatic way, you will see that in a video. So the upper punch descends, compaction and compression happens, the lower punch goes up to to put the tablet at the surface. شوفوا, this one should not go up more. If it goes up more, يعني لو lower punch goes above the surface here, higher, شو بصير? When the hopper shoe comes back, it will hit the lower punch. It will hit it. So we don't want this to happen. We want the hopper only to remove the tablet without touching the lower punch. طيب, إذن which one is responsible for the compression? اللي هو ال upper punch. Which one is responsible for the weight that is filled inside? اللي هو lower punch. Which one is responsible for the ejection? Lower punch. That's why ejection screw, يعني for the lower punch to travel exactly to the surface, is controlled in the lower punch screw. The capacity to be filled inside the die cavity is also controlled by the lower punch screw. أما الupper punch, with this one we can control how much the upper punch goes inside. وبالتالي what is the pressure that goes into the granules. Okay. طبعا what I described for you, this is mainly for single punch tableting machine. Single punch tableting machine or tablet press. In industry we have another type of machine. Why? Because this machine, loose single punch or single station tableting machine, will not be able to produce large number of tablets as required in industrial scale. We can use it in a small scale. Actually, if you go to the pharmaceutical technology lab that we have, you will find the single punch tableting machine from the company Erwica. It's a very excellent machine, and inshallah you will use it in pharmaceutical technology lab in your third year, second semester. In industrial scale, what you have is rotary tablet machine or rotary tablet press or concentric tablet machine. And you have seen this tablet machine when we were talking about multiply compressed tablets, سواء multiple layer tablets or tablet within tablet. You have seen this machine. It consists of several stations of punches. يعني it's not just a pair of punches, one upper, one lower. لا, we have several punches, upper punches, okay, and lower punches. And in between here, we have die cavities. Now this is available, or it rotates while in process. يعني while compression is happening, all the settings are rotating with each other. يعني an upper punch with lower punch with die cavity, okay, they rotate. That's why they call it rotary. They rotate all the time. طيب, initially, what happens? The lower punch goes down, the powder or the granules fill the die cavity. بعدين, after that, the upper punch descends and the lower punch also rises. Okay, the single punch tableting machine, only the upper punch descends. Here we have both punches for rotary tablet machine, that is upper punch descends and lower punch ascends or rises to do the compression step. And then the upper punch will go up, the lower punch will eject the tablet to the surface, and then the tablets get removed. These rotary tablet machines are able to produce so many tablets every hour, and there is even faster rotary tablet machine that is double rotary tablet press. For rotary tablet machine, you have one hopper, okay, one hopper with a feeding shoe and sets of dies and punches. Okay, be double rotary tablet press, you have two hoppers, okay, in the same rotation. يعني you have, for example, here a hopper shoe. You have hopper shoe here, and after the tablets, after the die cavity gets filled and compressed and ejected, then you have another hopper before the dies and punches complete the full circle. Reason I have here another hopper. Okay, so in one full circle, how many tablets get produced? 2 tablets. One from the first hopper after filling the die cavity, compression and ejection, and then the same die cavity, the same one, gets filled again by the second hopper after half circle, and then it gets compressed and then ejected. فإذا في عندنا 2 tablets are produced from each die cavity in each circle. Okay? See, it can produce in 1 minute, يعني 60 seconds, you can produce in such machine, you can produce 10,000 or more tablets per minute. Here you will see the diagram of rotary tablet machine. Okay? You will see here the feeder, اللي هو الهوبر shoe. Okay? Here you have the upper punches, here you have the lower punches. The lower punches will descend. طبعا this is to control the weight of the tablet. Okay? So you can control the weight by lowering or rising or raising the lower punches, little up or little down. So it will control the space here. So from the hopper shoe, the die cavities get filled. After that, see, the lower punch descends more, and then when the upper punch gets inside, the lower punch goes up in what we call pre-compression step. شوف في عندنا هنا pre-compression roll. The reason for this pre-compression roll is to remove any air inside. The presence of air inside can cause problem to the tablets. The pre-compression roll will remove and will consolidate the powder. And then I have the main compression where the upper and lower punches they compress harder. طيب. This happens very quickly while the upper and lower punches and the die cavity are rotating. يعني this happens while this is continuously rotating. Okay? While it's rotating, as I said, the lower punch gets down to be filled with powder formulation or granule formulation, and then it gets pre-compressed and then compressed. طبعا, as I said, this happens very quickly, and the reason why we need pre-compression is to remove, as I said, air, but also to allow more time for the granules or powder inside to be compressed. Now the problem, one of the problem of being very fast in producing the tablet is that there is no sufficient time for the granule or the powder to adhere to each other and get compacted properly. This is one of the problems. That's why even if my tableting machine can produce more than 10,000 tablets per minute, I don't want to go high in speed, because the higher the speed that I use, the more problem I will get with the tablet, and you will see this later. Also, it tells you that because of the speed of filling and rotation, it tells you that the powder here must get inside the die cavity very quickly, and this can only happen if you have excellent flowing powder. That's why in some machines they fit what we call induced die feeder. شو يعني induced die feeder؟ نعرف شو die feeder. This one feeds the die cavities. Okay. Induced معناته يحث, enhance, improve die feeding process. So in some machines they can fit agitator, as you see here. This is a motor to agitate the powder وين بالfeeding frame. هذا الفيدنج frame اللي هو الشو تاع الهوبر. So you want to fill the powder inside the die cavity here, okay? In order for this to happen very quickly, you need to agitate the powder in the hopper shoe Otherwise, not enough powder gets in, and if there is not enough powder because of high speed or because of bad flow, then less powder will get inside, and you will have problem with the weight of the tablet, with the mechanical strength of the tablet, etc. I will talk about these problems, but first, let us go back to the single station tablet machine, the one that you see here, okay, and see in a video how such machine can produce tablet. Please watch the video. Okay, what you see here, you see the hopper shoe. This is the hopper here, and this is the hopper shoe. And you see the upper punch descending when the hopper shoe leaves the place, okay? Later on, you will see also the lower punch and how the process is adjusted to produce tablets.
Similar adjustments for ejection height, fill depth, and pressure setting as TDP-1 and TDP models. There's also a similar flywheel for manual control, and as well as a feeder hopper to deliver the formulated powders to the feeder shoe. There's a special tool designed to dejam the machine and an on-off button for machine power. This is a close-up of the lower drift pin assembly. This is the ejection height control, and this is the knob for the fill depth control. This is a close-up of the upper drift pin and the area where you adjust the pressure for the upper punch. This is a side view of the TDP-5, of a better view of the on-off control box, and a view of the motor, heavy-duty motor that we put on these machines. It is possible to produce a tablet on the TDP-5 manually by spinning the flywheel around. The TDP-5 has a maximum fill depth capacity of 16 millimeters, and this machine will run continuous for hours.
Okay, I will show you also the Rotary tablet press. Okay, you see here one of them. You see this is the hopper, and these are the upper punches and these are the lower punches. We'll see this in a video now. These are the lower punches, and you have seen the upper punches. This is the pre-compression. And this is the final compression, you will see. Okay, what you see here, when the machine does the compression, they use sensors في الpunches to sense how much compression was applied. طبعا the compression, as you have seen in the previous demonstration, the compression can be regulated by the upper punch in single punch machine and by the upper and lower punches in the rotary tablet machine. Now, the problem is when we adjust, when we want to adjust the pressure, we adjust it indirectly by adjusting how much the upper and lower punch will get inside the die cavity. So if we regulate the upper punch and lower punch to go more inside the die cavity, this will cause higher pressure. If we adjust them to with lowering their distance they travel inside the die cavities, then we will have lower pressure, right? But if you don't have good filling inside the die cavity, what will happen? Let's say the die cavity should be filled completely, right? Now, if a partial or half of the die cavity is filled, then the compression will not be strong enough, right? Because when you adjusted the punches to travel inside, you adjusted it based on what? Based on full filling. If the die cavity is not completely filled, this will cause the compression to be weaker. And the tablet weight will be less كمان than what you expect. So you can monitor this in the diagram that you see here. If it shows lower compression force than expected, it means you have less filling and you are having problem probably with the speed at which the rotation of die cavities happen. There is no enough time for complete filling, or maybe the powder flow is getting worse and you have problem with the powder flowability. فإذا you can actually find out what will happen to the tablet weight just by watching the compression force. إذا the compression force can indirectly tell you about the tablet weight. The higher the compression force you get, it means that there is more powder inside. The lower compression force means there is less powder inside the die cavity. You see here the filling of the die cavities. Like compression, then ejection, compression, ejection. And you will see here a tablet de-duster. We need to remove dust. Similar to the case with capsules, we need to remove dust from tablets because these dusts can cause contamination, can cause other problems. Okay, what I want also to show you, I want to show you this diagram as animation while it's moving so that you understand the process better. Okay, I hope now you understand how tablet machine works. Now we will talk about some problems that you might see in the tablet. And particularly, I will talk about the horizontal striation that you might see in the tablet, such as this one. So after producing the tablet, you might see this one, okay, striation. تشقق يعني horizontal. You might see it in the body of the tablet as you see here, or you might see it in the top part يعني here where the curve starts, or at the bottom where also the curve starts, you have curve here. In case the striation or cleavage or تشقق happens at the top or bottom part, we call it capping. نحكي للمشكلة هاي capping of tablets. Capping of tablets. إذا كان التشقق, if the cleavage or striation happens in the body, as you see here, between here and here, you see this horizontal cleavage, then we call it lamination. Now, this you may see this when you inspect the tablet, you might see it. Sometimes you don't see it readily. There is a problem in the tablet, and there is weak bond between the parts of the tablet, but you are looking at the tablet, looks fine. There is a test that we will talk about it in quality control tests, according to the pharmacopoeia. When you do that test, if there is such problem that is not visible initially after producing the tablets, you will see it while doing that test. Even though that test is not for this purpose. يعني التست هذاك that I will talk about it later for quality control is not to detect this problem, but if this problem exists but you cannot see it still, the tablet will break while you are doing that test, and you will see that there is a problem of striation, lamination or capping. Now, what is the reason for lamination or capping? The reason for lamination or capping is, one, there is no enough time for bond to happen during compression. As I told you, even if your machine, tableting machine, is capable of producing very, very high number of tablets per minute, still you don't need to use the highest speed. You need to use appropriate speed, because if you use high speed, this means that everything will happen very quickly, even including the compression step. The compression step is not dependent only on the force that is applied. مش فقط أنا, for example, I want stronger force so I will have better bond. لا. It also depends on the dwelling time of punches. يعني how much the punches stay inside the die cavity. The longer they stay compressing the powder, the better, because this means you will have better adhesion of the formulation. This is one problem. Another problem is air entrapment. Also, if you do the filling of the die cavities very quickly, you might have air. And this is one reason why we have a pre-compression step, to remove any extra air that might be inside. The presence of air will cause a problem of lamination or capping. Keith, when the punches compress the formulation inside the die cavity, and there is air inside, air will also get compressed inside the formulation, forming a layer inside the tablet, air layer جوا الtablet. Now, when you release the pressure by the upper punch ascending and the lower punch descending, this air wants to expand layer تاع air inside the tablet. When it wants to expand, شو بصير? It will break the tablet horizontally and result in lamination or capping. Also, if you are using immaculate, not clean and not smooth punches, this will cause the formulation to stick to the punches because they are not clean. And while the punches are departing from each other, lower will upper, بيبتعدوا عن بعض, departing from each other, they may weaken the tablet. ليش? Because the tablet surfaces, they want to adhere to the punches. While the punches are departing from each other, this might cause the tablet to break. Also, too much fines in the formulation will prevent good adhesion in the powder formulation. That's why we need to control how much fines in the formulation. Now, the presence of fines is very important in the formulation, but too much fine is very bad. Usually maybe up to 5% of fines is okay. More than that, then you might be having a problem of capping or lamination. Also during storage, especially if it was improper storage, the material inside the tablet, like for example the drug, for example, might start changing in its form. يعني مثلا I'm using amorphous drug, and you took this in physical pharmacy 1. With time, it might change to crystalline in the tablet because of improper storage. This change will cause also lamination or capping. Sometimes even with time, the material that is stuck with each other by forming a tablet. This material was prepared under compression. This material, if it is elastic material, يعني مطاطي, for example, you have some material that if you press on them, they change in shape, but slowly they will come back to their original shape. So if there is elasticity in the formulation, with time they may break again from each other to retain their original shape, and this will cause also lamination or capping, as you see here. This is lamination. This is after the tablets are the tablet parts, upper part and lower part, is removed from each other. So you see how the rough surfaces are. طيب, because you know the reasons for lamination and capping, you will be able to tell us what are the solutions. يعني إذا عرف السبب عرف الحل كمان. طيب, after you produce the tablets and you inspect them for weight, etc., you need to do tablet dedusting. And this is like a hoovering machine. شوفوا هنا موصل على الهوفر. That sucks the dust from the tablet. One of the problems that we need to deal with in industry اللي هي what we call cross-contamination. Cross-contamination is that after I produce tablets, like for example Panadol, I need to clean everything. So no dust from paracetamol will be in the area where tablets are produced. So dusts are there, and you need to remove them because later on you will do packaging, and you don't want dust to be the formulation of tablets, the types of tablets, and the equipment used in making tablets, the methods for tableting, and we also talked about the defects in tablets such as lamination or capping. And as you see today in this title, we're going to talk about tablet coating. Now, two main types of coating we will discuss in this part. The first one is sugar coating, and the second one is film coating. Now, I wanted to go back to the section when we discussed about the types of coating, the types of tablets. And if you remember, we talked about the sugar-coated tablets and the film-coated tablets. So I want you now to go back to that section and read them carefully, and then come back to continue this video. Now, with sugar coating, if you remember, we said that among the reasons for sugar coating is to hide the taste and odor of the drug and other excipients that may be unpleasant. And another reason for sugar coating is to protect the ingredients inside from degradation because of moisture, oxygen, and light in the surrounding. But we have to be careful here because sugar coat itself can be affected by the moisture around. Don't forget that the sugar coat is water soluble. Another thing, as you will see also later, you remember that we said that sugar coating is thick and the tablet can have an extra 50% weight because of this coating. So we can utilize this coating in order to separate incompatible ingredients so that one ingredient will be in the shell or in the outer of the tablet, in the coating yani, and the other ingredient which is incompatible because of maybe different reasons such as chemical interaction or something else, we can put it in the core or in the inside tablet. So one ingredient will be in the outer coating, the other ingredient will be in the tablet which is being coated. An example of incompatible ingredients are the iron salts and other divalent metals, okay, which we can put them in the coat while we put, for example, the vitamins in the core of the tablet, yani in the tablet itself, rather than mixing them with the salts. Another very important characteristic actually of the sugar coating is that the appearance. You will see later that the last step of producing sugar coated tablets is waxing or polishing, and this polishing will give it a shiny and elegant appearance. طبعا of course you remember the disadvantages, which include ايش disadvantages. حكينا انه size will increase, and you will see also other disadvantages such as the time required to prepare sugar coated tablets, the expertise, and all of these can be considered as disadvantages, and later we will talk also about additional disadvantage. طيب, let's talk about the process of sugar coating the tablets. Well, there are several steps. As you see here, if you see A talks about waterproofing. But actually, prior to this, we must do dedusting. Yani, actually, the first step is dedusting. And if you look back into the production of tablets, the last step in producing the tablets, اللي هي ايش last step, اللي هي dedusting. So that is the step after producing the tablets, we do dedusting. Dedusting will prevent the coating from becoming rough. Okay, that's why we need to dedust the tablets. After that, we do waterproofing. طبعا we'll talk about this in more details later. And after waterproofing, we need to do subcoating. After subcoating, we do smoothing and final rounding. Then we do finishing and coloring, and the maybe let's say before or the last step is polishing, but before this and after we do coloring, finishing and coloring, we do something called imprinting. يعني إذا في هون كمان we have here imprinting step, and then we have polishing. Now, okay, now I want you to imagine the situation. We are having the coating pans. Coating pans are like cup-like shape or acorn shape. You know acorn, it's like a certain fruit from a tree. And this is how it looks like, okay? Although this is an old one, old style coating pan, but it can be used. You will see that it has opening here. Okay, you will see that there are tablets inside. This is a rotating pan, and there is an inlet for hot air and exhaust. Okay, طبعا modern coating pan will look like this, although even more recent equipment will be having the process in a closed way. Okay, now I want to show you a video showing the process of coating. Look at this video. These are coated, sugar-coated tablets. Okay, from these you have the pouring or applying the solutions or liquids. طبعا this is the coating pan. Okay, look here carefully into this figure. Okay, you will see that this is the, I will go back so you get the, okay, now this is the tablet, okay, inside this circle or this contour, okay, what you see inside, this is the tablet. This is what we call the waterproofing or sealing, as you see here the name. It's called waterproofing or sealing coat, the dark one. Okay, then you have the subcoat. You will notice that the subcoat is the thickest part of the coating. And then you will see the smoothing coat. Okay, اللي هي the step of smoothing and rounding. Okay, then you will see the coloring, finishing and the coloring coat. Okay, then after that you may imprint the tablet, put a logo or put, let's say, an imprint on the tablet, because this is nowadays required. And the final step will be polishing. Okay, you see here the air getting inside the coating pan. Okay, what you see here is the motor that will pump the coating solutions into the pan. Okay, through here you will have the liquid to do the coating. So this liquid goes into these openings to do the coatings. You see these liquids? These can be sugar in a water, which is applied to the rotating and tumbling tablets. Okay, I will stop here just to show you the modern coating technique. So let's go back to the coating process. As I said, the pan will be rotating and the tablets will be tumbling inside, and while they are tumbling they are making contact with the coating solution. طبعا after applying each coat, usually it is left to dry before we apply another coat. يعني there is not only one coating applied, but there are several coats to be applied, and the reason is to gradually build up the coatings until we get the right thickness. Okay, now we will talk about the process in more details. If you remember, I said in the beginning there will be de-dusting, and after that اللي هو waterproofing, or the other term we call it sealing coats. First we need to know why do we need to do that? Why do we need to do waterproofing or sealing coat? What do we mean by that? What does it mean, waterproofing? Waterproofing means we don't want water to get into the tablet, because later on we're going to use aqueous solutions, syrups. So the syrup, if applied directly to the tablet, it can dissolve the ingredients in the tablet, and this will disfigure all tablets and will create a mess. So in order to prevent that, we need first to do waterproofing or sealing. So how do we do that? We apply an alcoholic solution of a shellac, ومعروف الشيلاك, which comes from a bug. This shellac is resistant to water penetration, okay? Otherwise, we might apply Enteric polymer. If you remember Enteric polymer, زي مثل, like for example, polyvinyl acetate phthalate, cellulose acetate phthalate, hydroxypropyl methyl cellulose acetate, phthalate, sorry. So we have different Enteric polymer. In case we need to use them, whether shellac or the Enteric polymer, they must be ash. This is very important, in very small quantities, just sufficient to prevent ash, water from getting inside the tablet, just enough. Yani it will be very thin. So this solution is sprayed on the tablets that are being rotated inside the coating pans, and then air is blown in order to dry these tablets and preventing them from sticking together. Then, after the dusting, we have to apply a thin coat. Okay, this thin coat, what is the function of this thin coat? Is to prevent the subsequent solutions. Later I will add more aqueous solutions, and these will destroy the tablet. So this thin coat will prevent this from happening. Okay. Now subcoating, this comes after waterproofing, and it is maybe the main coating that is applied, which produce the large thickness of the coat. Its job, let's see what's the job of this subcoating. See, first it provides rounding to the tablet. Okay, it provides rounding to the tablet. That's why when we look at sugar coated tablets, you will see that it's not spherical, okay, but it is rounded, especially from the edges. And another thing which I forgot to tell you, even the tablets that we use, to do the sugar coating, they must have convex and thin edge. Yani the sugar coated tablets, before coating them, these tablets must be produced so that they have thin edge and convex. يعني كل مكان, the more it's spherical, the better. And the reason is the tablets will be rounded and tumbling all the time. Okay, all the time it will be tumbling. If it has a sharp edge, like a contour, like a flat surfaces and sharp edges, then this can break the tablet and make the coating more difficult. That's why we need such tablets to be used. طيب, subcoating the main thing is to make the rounding. Number two, it provides the bonding between the sugar coating, which will happen at the end, okay, the final coatings of sugar coating, and the tablet. يعني it will provide the bonding in order to bond the final coats with the tablet itself. Now this coating is applied 3 to 5 times. يعني each time we apply it, then we need to dry it, and then apply it again, and then dry it again, apply it again, and then dry it again. This happens 3 to 5 times. Now the solution we apply contains, in addition to sucrose, okay, the syrup that I'm applying, in addition to sucrose, it contains gelatin or a material such acacia or polyvinyl pyrrolidone in order to enhance coating and make the right bonding, okay, because these materials help in bonding the coat with the tablet. Now after applying the coating, okay, we start drying these tablets. When they are partially dry, yani not completely dry, they are still have some moist on them, then we need to sprinkle a dusting powder. Now the dusting powder job here is to help in drying, to help prevent sticking of the tablets together, okay. So these dusting powder that can be a mixture of sugar and starch, and may also contain talc, acacia or chalk اللي هو الكالسيوم carbonate. We sprinkle that on the partially dried tablets, and then we continue drying and while the tablets while the coating pan is rolling, okay, we continue the drying until the tablets are completely dry. Now this process is repeated. How many times? As I said, 3 to 5 times. طيب, at the end, we remove the tablets from the coating pan. We clean the tablets from excess powder. Okay, we clean the coating pan and then we return the tablet again. But before we do that, we make sure that the thickness of the subcoat is now thick enough. Yani we attain the required thickness of the subcoat. That's why you will see a gauge here. Okay, gauge, yani to measure the thickness, مقياس, to measure the thickness. They put, for example, 10 tablets in order to see the average thickness of the coated tablet and whether we received or we obtained the required thickness. طبعا, one of the problem of sugar coating, as I will tell you later, is that we don't have exactly the same thickness for all the tablets. So there might be little variation in thickness, and this is considered as a problem. طيب, after we finish the subcoating, we put the tablets in a clean coating pan, and then we apply from 5 to 10 coating of a thick syrup. And this process is referred to as smoothing and final rounding. Okay? The coating here will be smoother than the subcoat. The subcoat is more rough. And the coating solution is actually a thick syrup, and it can contain additional ingredients like starch and calcium carbonate. And after we apply from 5 to 10 coating, and between each coating and another we need to do drying, and we may apply a dusting powder to prevent sticking of the tablets together. After that we do what we call finishing and coloring. Now, coloring can be is optional, of course. If you need to add a coloring agent, then you add it to a thin syrup. Thin syrup indicates that the viscosity is low, okay? Because now you need something smooth. That's why you use thin syrup. معناته the concentration here gets lower. And we may add the appropriate color that we need. طبعا, we must do this in a clean pan. This is very important, because now we are doing smoothing. We don't want any powder to be there in the pan or on the tablets. Okay, so we apply several coatings of this, and after that, طبعا, between a coat and another, we have to make sure that the tablets are dried and they are not stuck to each other. طبعا the tumbling of tablets and the continuous rotation can help prevent tablets from sticking to each other. طيب, after that, when the tablets are ready, we take the tablets for imprinting. Imprinting means, as I said, we need to provide a code or some sort of identification to the tablets. From 1995, the FDA now requires almost all tablets to bear some kind of identification. That's why sugar-coated tablets will be imprinted طبعا with edible ink, okay, يعني permissible ink, and then after that it will go for polishing. طيب, before I talk about polishing, طبعا as I said, from 1995 all tablets must have some kind of identification. طبعا the reason for that إنه خاصة في USA and also some other countries, the tablets might be supplied without the manufacturer packaging, okay, and the pharmacist might provide it by mistake without proper labeling, and the patient by mistake might throw the package away and use the tablets. And to be able to identify the tablets, you need to have some kind of mark on the tablet. That's why they must have some kind of identification mark. طبعا there are some exemption. An exemption like radiopharmaceutical drug products, like for example when you use drugs in clinical trials, okay, or clinical investigation. Of course, you don't want the patient to know what he's taking. You don't want the investigator to know what he's giving. So there are some exemption that all tablets must be bearing certain identification codes. Okay. طيب, here you will see a machine that takes the tablets. First, it will rectify them. Okay. يعني تصححهم. Okay. Rectify them so that they are horizontal. Okay, because they come randomly positioned زي الكبسولز. Okay, so they get rectified, and here you will have the printing on the tablet, and the tablets come out as printed. The last step is polishing. Now, polishing is done in one of three ways. You can use the same coating pan, okay, but this coating pan will be lined with canvas or cloth, and this cloth is impregnated شو يعني soaked. يعني first you soak the lined cloth, يعني the cloth that is in the coating pan, you soak it first with a wax. This wax can be carnauba wax, اللي هو palm wax also, the same thing, or beeswax. So first you impregnate the cloth بالواx, and this cloth will be lining the coating pan. After that you add the tablets and you start automatically rotating the pan until the required glossiness is attained by the tablets. The other way is to take a piece of wax and put it in the coating pan, and then allow the tablets to tumble and rotate until they get the required shininess. The third way, and this is I think more commonly used, اللي هو dissolving the wax in an aqueous solvent and then apply 2 to 3 coats of wax into the tablet to acquire the desired glossiness. Now sometimes they add a small amount of talc during tumbling to contribute to its glossiness. يعني الtalc will also contribute to the glossiness of the tablets. إذا في عندنا 3 ways. 1, cloth lining the pan impregnated with wax. 2, adding a piece of wax. 3, spraying 2 to 3 coats of wax. These are the way to do the polishing. Please note that here we are doing polishing. It's similar to polishing shoes. Okay, so we intentionally doing the polish. That's why sugar-coated tablets are characterized or something distinguishing them. شو هو؟ they have shiny appearance. Okay? Another thing to distinguish sugar-coated tablets, they have rounded edges. بسبب الcoating that we apply and the shape of the tablets we are using, and because of continuous tumbling, there will be they will have rounded edges. Okay, so you can see here the imprinting on the tablets. Now, film coated tablets. Also, as I told you in the beginning, I need you to refer back to the film coated tablets to see what are the advantages and disadvantages of these tablets. For film coated tablets, طبعا first, it's less tedious to do the film coating. Just a while ago, I described several steps in sugar coating. It's really tedious and it needs the intervention of the operator several times. Number 2, it's time consuming. Number 3, it needs expertise. Number 4, the size may be up to twice the original size and the weight increases, and this can cause بالنسبة للpatient. He will not be easily swallowing these tablets because of their size. And not only that, but as I explained earlier, the tablets might slightly vary in size, okay, because we cannot guarantee that the coats applied to all tablets are exactly equal. So film coating is thinner. Actually, they estimate that the film coating increases the weight by about 3%. يعني from the tablet weight after coating, if you weigh it, then about 3% will be the film coat. طيب, if you are doing sugar coating, it will be 50% and maybe even more. So it's a thin, skin-tight coating. Skin-tight here is to tell you that it will actually help in protecting the tablets. Okay? Now, because it's thin, the film coating is thin, if you have any identifying monograms or scores, if you remember, the scores, the grooving, the grooves, or the scores, in order to help you break the tablets. يعني if you have that and you apply thin coating, still these grooving and crevices, they will be visible and they will be revealed to you after the film coating. But if you apply sugar coating, this will not be possible. You need to do imprinting after you apply the sugar coating. As I told you, film coating can give the tablet durability and it becomes more resistant to destruction if you compare it to sugar-coated tablets. Now, to do the coating, the film coating, you can do it by non-aqueous or aqueous method. Non-aqueous should be easier because the liquid in which you are dissolving the polymer or you are suspending the polymer, this liquid will be volatile and it can evaporate quickly without really harming the tablet. If you use aqueous, you have the probability of affecting the tablet itself by affecting the ingredients in the tablet. But even though this may be easier, this one is safer and cheaper, اللي هو using aqueous preparation. Not only that, but from environmental point of view, using aqueous vehicles are much preferred than non-aqueous vehicles. That's why in an industry they generally favor the use of aqueous solution. طب شو المشكلة? What's the problem? Slow evaporation, okay? And another problem is that it can affect the tablet ingredients. One of the commercial product contains 30% ethyl cellulose as a coating material. It's a colloidal preparation. Ethyl cellulose is not water soluble, so it can actually prevent water from getting into the tablet easily. But there are some other also polymers that we can use that are soluble, such as methyl cellulose, hydroxypropyl methyl cellulose, and others as well. But what is good about this preparation is that it contains 30% of the polymer. The polymer will be responsible for the coating, the main coating material of the film. Now, the good thing about this, as you see, 30% is considered as high concentration. معناته the vehicle is اللي هو water, which is available as 70%, let's say, is considered as between brackets as not very large. Okay, of course it's large, but the concentration of ethyl cellulose is very large in this preparation. This means that you need less time to do the evaporation. The other good thing about this preparation, even though it has high concentration of ethyl cellulose, the viscosity is low. طيب, what is the benefit of having low viscosity of the material you want to spray on the tablet? شو benefits? يعني when I say low viscosity, is there any benefit? Of course, there is a lot of benefit. One, the liquid can get into crevices أو into grooves. يعني إذا في for example monogram in the tablet, في هناك marks في الtablet that I've put them, they can get inside and you can see these crevices because they don't build a bridge. ما بيسووا bridge. They don't make a bridge and cover the crevices. No, they can go inside. Why they can go inside? Because they have low viscosity. Okay. Also, the evaporation will be faster. You require less evaporation because you are providing large concentration of the polymer. طيب, in addition to the vehicle, which is in this case water, you need to add plasticizer in addition to the polymer. يعني in addition to the polymer, you need to add a plasticizer. Now, plasticizer is very important because it makes the film coating or the coat, it makes it more dense. Also, it makes it impermeable film. يعني the film will be intact, all netted with each other or all together. يعني ما في spaces between them. They do not, like if you want to break them, to break the film, it's elastic, okay, and it's connected with each other. That's why it provides a better mechanical strength to the tablet and the film. Also, another job for the plasticizer is it gives glossiness, يعني لمعان, glossiness to the film coated tablets. As I said, There are other polymers other than ethyl cellulose. You have methyl cellulose, hydroxypropyl cellulose, you have hydroxypropyl methyl cellulose. So these are other polymers that you may use. So what is the constituents or the composition of a film coating solution? Number one is the polymer, or what we call is the film forming polymer. And in our example, we talked about special polymer preparation that is available in the market with a 30% ethyl cellulose, and this is considered very high. Normally, the polymer concentration will be from 7 to 18%. Of course, the more the better, but there will be a problem regarding, as I said, viscosity, okay? Viscosity of the preparation, and if the preparation is very viscous, you will have problem with spraying it. You will have other problems with the tablets. Plasticizers, examples of plasticizer that you may use with a concentration up to 2% include glycerine, propylene glycol, polyethylene glycol اللي هو PEG, diethyl phthalate, and dibutyl subacetate. Now, if you need to color your tablets, okay, then you can add coloring agent to the coating film solution. This coloring agent, as we discussed in capsules, include FD&C. FD&C abbreviation for what? For Food, Drug and Cosmetics approved, and Drug and Cosmetic approved lakes. Lakes يعني اللي هي pigments أو colors. And we have other pigments of iron oxide. Iron oxide can come in different colors like brown, black, etc. In addition to that, of course, the vehicle, usually water, to make the full preparation. These are the ingredients that you may find when في film coating solutions. There can be problems, especially when you are using aqueous film coating. يعني the process of coating can result in certain problems. Let's see these problems. What you see here is peeling or flaking, and if we look deeper, you see here the flakes. Okay, these flakes. Sometimes while the tablets stick to each other, and then when they get dry and then you separate them, flakes will appear. This is a problem. Okay, here you see what we call orange peel effect. If you look deep or carefully into these tablets, you will see them like rough surface. And the reason for this rough surface is when the polymer solution was sprayed, the drops on the tablet should have spread, coalesced together, يعني يندمجوا مع بعض, spread as a film. But they failed to coalesce with each other and spread as a film. And one important reason could be the high viscosity. إذا شفتوا كيف high viscosity is a problem. إذا the high viscosity did not allow the film to distribute evenly on the surface of the tablet. If you look here carefully, you will see pitted surfaces. Pitted يعني منقر. Pitted. This is called picking. And this can also happen when tablets, while they are tumbling, they stick to each other, and when they depart from each other, they pick from each other. Okay, additionally, you will see here different intensity of color. Some places is dark green, some of them are light green, and when you have something like that, this is referred to as mottling. إذا شو mottling? Mottling when you have different shades of color on the tablet. يعني the tablet contains area of dark and light colors. Another problem is what we call bridging. Okay, bridging is when the coating film gets to the monograms or to imposed logo, and instead of getting inside easily and outside to leave the logo clear and sharp, it makes like bridges. So what it's doing is like it's disfiguring, or let's say it's covering the logo rather than getting inside and outside to leave sharp logo. But this is, we call it bridging, okay, because it's not getting inside deeply and then outside. It makes like a bridge. And one reason is also the viscosity. شايفين why viscosity is very important? Okay, what you see here is tablet erosion. Tablet erosion. Because you are using an aqueous solution of the polymer, what you have here is erosion of tablet. يعني the tablet core is getting eroded. يعني getting dissolved. Okay? طيب, what you have here, you have also different shades of color, light and dark. What do we call this? Mottling, as we already discussed it before. So let's go back here and discuss the terms because they are important. When you have picking, this means the reason is the tablet sticks together and then part, causing picking. Okay? Peeling لما يكون في هناك fragments flaking from the tablet surface. طيب, orange peel effect اللي هو roughness of the tablet surface due to failure of spray droplet to coalesce. طيب, شو uneven distribution of color on the surface of the tablet? We call it mottling. طيب, filling in of the score line or indented logo on the tablet by the film. يعني بصير هناك filling instead of getting inside and then getting outside, okay, of the score. It causes a bridging. But disfiguration of the core tablet when subjected for too long to the coating solution, شو بنحكي لها? We call it tablet erosion, because water keeps eroding the tablet and dissolving the tablet. That's why it should not be left for too long while getting coated. Okay? And coating should not take very long. We should not apply very large amount of coating material. Okay, Enteric coating. Okay, it's a type of film coating, isn't it? Normally, Enteric coating is a film coating. It's one type of film coating. It's not all film coatings are Enteric coating. No, it's a type of film coating. يعني if we use a polymer that is enteric in nature, يعني enteric, its function is enteric, then we call it enteric coating. طيب, how do we do the enteric coating? In the same way, like film coating, but the polymer that we use is a special polymer. طيب, now number 2. The material that we add for enteric coating are either transit time dependent or pH dependent. يعني we can classify the material that we add for enteric coating لا transit time dependent or pH dependent. شو يعني transit time dependent? يعني we apply coating with sufficient thickness so that when all the coating dissolves, the tablet at that time will be in the intestine already. Do you get it? يعني the coating will dissolve even in pH condition of acid, okay, or in the stomach, it will dissolve. But there is sufficient thickness that it will take some time before this coating dissolves. By that time, the tablet will be already in the intestine. You know, you heard about stomach emptying time. And for example, when you eat food, how long will it take for the food to get to the intestine? Maybe 2 hours, maybe 3 hours, right? طيب. So we apply enough thickness of a coating until so that when the tablets gets to the intestine, by that time the coating will have dissolved. طيب. Example of that اللي هو الشيلاك. الشيلاك اللي بيجي من البق is an example. But most commonly what they use is a polymer that depends on pH factor اللي هي زي cellulose acetate phthalate, polyvinyl acetate phthalate. They depend on pH. At acidic pH يعني 1, 2, 3, 4, they will remain intact on the tablet. But when pH goes 5 or 4.8 and above, then they will dissolve. طبعا some polymer will dissolve at 4.8, some polymer will dissolve at 5.8, and so on, depending on the type of polymer that we use. Now this polymer can be applied to the whole tablet, or it can be applied to the granules or particles of the drug, and then fabricated into tablets, يعني compressed into tablets, or filled in capsules. Okay. If we want to do coating by a special method, then we can use what we call fluid bed or air suspension coating. Okay? You remember the fluidized bed process where the powder gets mixed and then you spray the powder to make granules and then you dry these granules. Now we can use very similar equipment to that in order to coat the tablets or the granules with a film coating, whether this film coating is enteric or non-enteric. Okay, I forgot to tell you about something. You remember when we talked about sugar coating? You remember the process of waterproofing or sealing coat. Now what did we apply? We applied shellac, okay, or an enteric polymer, which is the same situation as what we are talking about here. يعني نفس السيتويشن. طيب, إذن can we say that sugar coating is enteric coating as well? No, we cannot say that. Why? Because for waterproofing we are applying a very small amount of enteric coating that is not capable of behaving like enteric coated tablets. But remember, if we do apply enough quantity, then the sugar coated will behave like like enteric coated tablets. Remember this. طيب, do we normally do that? يعني هل احنا, for example, when we prepare sugar coating, we prepare it because we want to do enteric coating? The answer is no. Normally we do it with film coating because it's easier and faster and it does the job. So why do we go for sugar coating? So normally if I want to do enteric coating, I will go for which type of coating? Film coating or sugar coating? The answer is film coating. طيب, another question. Can I do enteric coating with sugar coating? Yes, I can. Okay? طيب, now in this fluid bed process coating, I want to show you the figure here, which is similar to the fluidized bed granulator. Okay, look at this figure A. In this figure A, you will add the tablets here. The air will come, will fluidize the tablet. While they are getting fluidized, suspended, and at the same time rotated horizontally and vertically. At the same time, you have spray from the top. هذا spray is spray of polymer. Okay? Now, this configuration or this setting can accommodate the largest number of tablets compared to other configuration that you will see, B and C. Okay? It can accommodate 1,500 kilogram of load. Okay? طيب, the other one, you will see that the air comes from the top. Okay? So the tablet goes similar to this one, but additionally, the spray of the polymer solution comes from the bottom. And this is what we call bottom spray configuration or Worcester fluidized process. Worcester is the scientist who actually did this, okay? Yani made this setting. The other one is the tangential spray, where the spraying solution comes tangent. We have the tablet rotating in this way. At the same time, you have the spraying tangent to the rotation of the tablet. طيب. See here the tangent spray. This is the bottom spray, and this is the top spray. Okay. طيب, طبعا in the spraying method you have to control several parameters, such as what equipment I want to use and what is the method of spraying, is the top, tangent or bottom, what is the distance of the spraying nozzle from the tablets, what is the droplet size that is emitted from the nozzle, what is the spray rate, what is the pressure, what is the volume of the column, how much is the size of the column, the time for drying, etc. We have to control all these parameters to get good spraying. One of the common problem with this method, because it agitates the tablets, it suspends and agitates the tablet. One of the problem, شو هي؟ إنه the tablets hit each other and they may break. Okay? This is one of the common problem, because the method used here is really tough to the tablets to withstand. Okay, the last type of coating is compression coating. Like for compression coating, I want you to go back للمultiply compressed tablet والتايب اللي هو tablet within tablet. في عنا core وفي عنا shell. Now, I can do sugar coating بدراي method. كيف؟ by compression. يعني the core tablet will be prepared, and then the other materials will surround this tablet, okay, and will be compressed on the tablet. It's completely anhydrous operation. There is no heat involved. There is no water involved. I will show you the video again so that you can remember what I'm talking about. Remember this machine, these are the core tablets here already prepared. Now they will get to a circulating or a rotating plate containing cavities. To take each cavity will take one of the core tablets, طيب, these core tablets will be located exactly at a center of a die cavity. This die cavity is already partially filled with the coating material or the shell material. Then it will be compressed. بعدين the rest of shell material will be added and will be compressed again and then ejected. This is the video that I have showed you before, and I will show you the video again now. Okay, so what you have seen is a video that I showed you before. We can apply that as sugar coating material. The shell will be like the sugar coating. Of course, I can put a drug in this shell or the outer coating. As I told you, the good thing is anhydrous, so it's good for material that is affected or liable to moisture. The other good thing about this is that the tablets are more uniform in size. If you remember my explanation about sugar-coated tablets, the conventional one, I said that the tablets might have little variation in their sizes because of the coating material not really accurately controlled. But with this method, you can control it better. It's also lighter and smaller and easier to swallow. Yani the coating material in this case can be less than the sugar coating, the conventional sugar coating. But of course it will be much more than the film coating at the same time. Also, it's less expensive to package and ship because it's smaller, and this is the reason for that. Okay, now we will talk about a new thing that is the quality control of tablets. And I want you here to remember what we talked about in capsules, because capsules have similar tests to these tablets. Not exactly the same, but similar. During the process of tableting and after that, you need to test your product, whether while making your product or after you produce your product, اللي هو الtablets. So you have in-process control and you have after the production control tests that you have to do. Now, why we are doing the tests? Now we are testing here. Okay, we are not assuring anything, we are testing. We are testing the claimed amount, for example. If we are saying that Panadol tablets contain each 500 milligram, then this should be accurate, right? But this is one thing. So you want to make sure, or you want to test the claimed amount. Another thing, every time you produce your batch, the specification of the batch you produce every time must be the same. مش مرة, for example, Panadol tablets are faster in dissolution, then when I produce another batch it becomes slower in dissolution. No, they should have the same specification in terms of dissolution, in terms of claimed amount, in terms of uniformity of content, etc., etc. That's why we need to do these tests, and the product will remain in quarantine area, يعني محجوز, until the quality control lab gives okay for it to be released to the market. Now, the quality control tests can be classified to 3 types of tests according to the type of test. It can be chemical tests, okay, well, this is one. It can be physical tests. It can be microbiological tests, okay. Then how many class of tests do you conduct? I conduct three types of tests: chemical, physical, and microbiological. I will talk about microbiological now because I will just go through it very quickly, and then I will talk in more details about chemical tests physical tests. For microbiological tests, what you need to do. My question is, are the tablets produced for oral administration? Because normally tablets are for oral administration. Are they sterile? This is my question. Okay. Or they are supposed to be hygienic? Now the answer is no, they are not sterile. They are supposed to be hygienic. Sterile means what? Complete absence of viable microorganism. ما فيش أي microorganism. Do I need to do that? Do I need to produce tablets that are completely absent? في هناك complete absence of viable microorganism? Well, I can do that, but that will cost me a lot of money and for nothing. Because you see, our mouth contains microorganism, our intestine contains microorganism, a lot of our body contains microorganism. But it's important for tablets not to contain pathogenic microorganism. This is one, should be completely absent, yes. But for other microorganisms, there should be a limit. And if there is a limit, we call it hygienic. Okay, when there is no pathogenic bacteria, and I'm limiting the amount of other bacteria that are not harmful, then we call it hygienic. That's why if you go to industry, and you will notice that they are trying to keep everything as clean as possible. Okay, the water is distilled water. They wear special covering on their shoes. They cover their heads. Okay, فإذا that's why they are trying even to control the air by controlling the number of particles that is in the air. Why they are doing all this? Just to make sure that the tablets they produce are hygienic. Okay, so if you take 1 gram from the tablets and you test it for microorganism, طبعا you will learn about how to do that in microbiology. How to take sample from the tablet, how to culture it, how to put it in incubator, and then see whether bacteria grow or not. Anyway, in 1 gram there should not be more than 10 to the power of 3, yani 1000 bacteria, and not more than 1 to the power of 2, yani 100 fungi per gram of the preparation. In case the preparation is liquid, then it's per milliliter. For E. coli, which is a pathogenic bacteria, قديش لازم يكون؟ 0.